Okay, so in this video, we're going to introduce the concept of nutritional minerals. Now, previously we have talked about vitamins and the key role vitamins have. So we're going to introduce minerals. Now, if you recall, when we talked about vitamins. Vitamins were either fat soluble or water soluble. They were compounds. Um, and they had tend to be cofactors or co enzymes in various different processes, many related to ATP production, or with fat soluble vitamins, very specific processes. In some respects, minerals have some similarities in that sense. They tend to be important in very key processes. However, there are some things that makes minerals different. One of the biggest things is that minerals are just that, they're minerals. They are elements that you can find on the periodic table. So these aren't compounds, right? And that's one key difference, as we'll see when we get into minerals and how they function, and even more importantly, things related to how much they degrade or are altered by pH or things like that. Now, if you recall from chemistry at some point, you may remember the periodic table, and there are a lot of elements there. Well, we are not going to focus on all of those. And generally speaking, most people would say there's probably between 10 to maybe 19 um, minerals that are somewhat important to humans. We're going to keep it at about 14 or so that I think are essential. You can make some argument over some of the more trace minerals. And like vitamins, they do have a wide variety of functions. This could be related to bone formation, like calcium and phosphorus. Importance as far as electrolytes, many of these are electrolytes, like sodium and potassium. So they're going to play a lot of different roles. Now, we generally divide minerals into two categories, major minerals and minor minerals. Now, major isn't better. In fact, some key minor or trace minerals are really, really important, like iron. But major minerals, generally, there is a much greater requirement of those. The DRI of those is quite a bit higher. And they generally are far more prevalent in the human body. Now, as you can see from this graph, we are ignoring some other elements on the periodic table, carbon, hydrogen. Those are components of macronutrients that we discussed previously, so we don't really discuss those when we talk about minerals. And as you'll see here, a few of these we'll go through far more in-depthly in future videos. Calcium, phosphorus, sodium are some big ones. Potassium we'll devote some time to when we get to electrolytes. So those are all some key major minerals. Minor minerals, again, sometimes called trace minerals. These generally, the DRI of these is a lot less. However, it doesn't mean they're not unimportant. And some of these, like zinc and iron, iodine, can be incredibly important for some very specific functions in the human body. And so we don't want to discount that. And so, like I said, we're going to go through a few of these, kind of like with vitamins. And not surprisingly, with these minerals, there are going to be some things I want you to know about them, very similar to vitamins. What its name is, which we'll see with those. What foods can they be found in? What's their function? And is there a disease or disorder associated with a deficiency in some of these? And there are for a couple of these. So some key things again to understand about minerals. These are atoms, right, of the same element. These aren't compounds, right? Another big thing is that these don't contain carbon. They're not organic, and that's important because they're not organic. They're not going to be destroyed by changes in pH, excessive heat, um, contact with oxygen, and so unlike what we talked about with vitamins in regards to cooking and things like that, that they get altered, not the case with minerals. And so definitely a little different when we talk about these. But these generally don't get broken down during digestion and absorption. Everything else we've talked about so far, it gets broken down in some way, especially obviously macronutrients, right, in the small intestine. That's not really the case with minerals. These are so small, they are generally readily absorbed. Now, that doesn't mean there aren't things that affect absorption of these. That doesn't mean that we may have issues where we don't absorb these well, but those situations definitely occur. But generally, these aren't altered a whole lot during digestion. And not surprisingly, these minerals that we need in our diet are generally going to come from what we eat, and often those are going to be plants that grow out of the ground. Soil is full of minerals. We consume plants that have those minerals, or it'll be in animals that consume those plants, right? Kind of like the whole food cycle, I guess. And so generally that's how we're going to get minerals. We don't really have situations like with vitamin D where we can make that ourselves. That's not really the case with minerals. We can't make minerals really. So definitely a little different when we talk about minerals here. So in the next videos, we're going to walk through some key minerals: calcium, phosphorus, sodium, iron, why they're important, what foods they're found in, and then what diseases or deficiencies that there are that exist with those. We'll see you in the next video.